So up to now, we've learned that we can create a variable name, and we use that name to refer to a memory address or a location in memory that we've set aside that stores our data. So we're going to take that a step further, and we're going to define what type of data goes into that memory location and why we care what type of data goes in there. And we're going to see how those definitions affect our program. So what we're talking about is called data types, and it's just that. What type of data are we storing in those variables or a memory location? What we're talking about when we're looking at when we're talking about memory location is RAM. And RAM is that special part of our memory in the computer that's set aside that is only on when only accessible when the computer is on. It's temporary storage, and programs load into RAM when they're running, as well as store our variables when they're running, because that's the fastest access to retrieve data for the computer. And then, as you know, when you turn the computer off, all of the information in the RAM disappears, so that's why it's temporary. But it's a fast storage location that our computers run in and our computers use to access data that it needs during the course of its program. So this is the area of memory we're talking about when we're talking about setting aside location for our variables. One type of variable is an integer. And the reason we care about the type of data, the data type, and why we're trying to define it is because integers, let's just talk about integers. Integers are just that, whole numbers. They don't take any decimals. And they don't require as much space in memory as perhaps a decimal or what we call a floating point. And so if we know that our data is going to hold something like maybe age is always a whole number and therefore doesn't require as much space in our memory. Remember that RAM it's a finite resource, and so we want to be very careful on only allocating the resources that we need so our programs aren't memory hogs. And so we might say that a variable that we're creating is only going to hold integers. We call it int for short because we're cool programmers. So you'll see the word int a lot instead of integers, but this is what we're talking about. You'll also see the word floating point, also shortened for floats. Some languages call it decimals, even though you and I see that as decimals, but mostly you're going to receive any location memory data type that's holding decimals is known as a floating point or floats, because decimals potentially need a lot more placeholders. Floating points take up much more slots in memory, much larger memory locations allocated than an integer. Okay. We've talked about strings. Strings is what we've been putting in quotes. We call string anything that's in quotes and it's a collection of characters. It could be dollar signs, it could be words, it could be numbers, but a string is the largest amount of spaces that are allocated in our variables, but they hold just string characters, strings, collections of characters. Here we have what you just defined 3.141 as a floating point because it's a decimal. I did, but as soon as we put a dollar sign in front of it, this is now a character, and so therefore this is now treated as a string. And we'll see why that plays into an issue later on. We also have something that's called a Boolean. And Boolean is simply true or false. It's 1 or 0. That's it. So it takes up a very small amount of memory. And you're thinking, well, why would I want something that's true or false or 1 or 0? Well, you'll see where this comes into play. Very useful very soon. But notice that it is a data type. So we can refer to a data type as a Boolean, and this can only receive a true or false or 1 or 0 value. Incidentally, 1 or 0 is also true or false. If we use the number 1, that is the same as saying something is true. If we use the number 0, that's the same as saying something is false. So that's why I say true or false or 1 or 0. Another one that we might not deal with too much in this class, but you will see it later on, is what we call a char. And a char is just one character. It could be a dollar sign, it could be a Y, it could be any string, anything that we've seen before, but just one. It can't be YES or something along those lines. A char is just one character. Probably won't be playing with that too much in this class, but at least you're starting to see it. So these are data types. These are different ways that we can say what type of data is going to be stored in our variables and how much space in memory does that data type require. We don't have to set aside that space. The computer's already going to figure that out for us. If we say a floating point behind the scenes, the computer knows, oh, that means I'm going to need quite a bit more space than I would if this is an integer. In other words, I need to preserve all of this location to hold the largest number possible that they're going to need to put into this particular data type. So what you're kind of getting to see here is that when memory is set aside, it's not set aside based on the value that we're putting in it. The memory location that's being set aside is a large bucket. It's creating a bucket that's going to be large enough to store whatever data type we're going to put in there. Okay? So now that we're aware of data types, let's look back again at this plus sign that we've been working with before. And we've seen the plus sign working on strings, and I said when it's working on strings, we're going to think of it as a join and not a plus. In other words, when we have this statement, print hello in quotes, so this is a string because they're in quotes, with this plus sign, and then another string because it's also in quotes, that simply says join these two strings together. So this is what would be output from that join print function is what it's called, but we'll look into that a little bit later. If we can also join two strings, one that might be a string and one that has a variable. So in other words, here we set aside a variable name, username, and in it we've put this string, world. And so back in memory, there's a very large space in memory that's been set aside for a string. And in that bucket, in that memory spot, we've put this word hello. This joins those two together. In other words, it joins our literal string, hello. In other words, literally type what's in my quotes. And then join whatever is in that username bucket or memory location. In this case, what's in there is the word world. And so what gets joined together is our word hello, and then what was ever in the username. And again, remember that because username is not in quotes, that's how the computer knows that this is a variable name and to go look into that memory location. Had I put it in quotes, this would have behaved differently and it would have printed out hello username. Because it's not in quotes, it's looking at the variable value, what's being stored in that variable, and in this case, it's world. So here we're joining a literal plus a variable. Contents of a variable, I should say. Okay, this is really important. I keep stressing the fact that strings are in quotes. So we're looking now at behaviors of these data types. In other words, here I've put a variable name that I called grade test 1. And again, because I've named this variable something, you might intuitively know that this is probably someone's grade for the first test. And in grade test 1, I put in quotes 95. That makes 95 a string, not an integer. And I'll show you why that's important in a minute. Grade test 2 is also a string 85. And so now the computer thinks that the computer's not smart enough to know that these two are actually numbers that are being put into string. It's simply being told that these are strings. And we saw here that anytime we see strings, they're supposed to be joined. And so if we print grade test 1 plus grade test 2, in your mind, it's 95 plus 85. But in the computer's mind, it's joining those two values together. So this would be the output of 9585, where it's just joining the two strings. It's not smart enough to know that those are numbers. It says you define these as strings because you put them in quotes. Therefore, I'll treat them as strings, and I'm just going to join them together. If we actually wanted to add them, we would need to make sure that they were in fact ints. And these are now ints because they are not in strings, in quotations. And so now the computer is going to look at this as, oh, this is an integer, it's 95, so therefore 95 plus 85 in this case means add them together, and so therefore it will. So it's very important to get this concept of strings versus other data types. In other words, this would be an integer. And it's an integer because it doesn't have decimals, and it also doesn't have quotations around it. So you have to really start paying attention to how you are assigning your variables. And I'm going to reiterate here that we have a variable name that's on the left-hand side of my statement, and the values that we want to put into our variable is on the right hand of our statement. Notice that's true no matter what we're doing, whether we're using strings to assign values to our variables, whether we're using ints to assign values to our variables. Our variables always go on the left, and whatever we're assigning it to is going to go on the right. So here we're assigning 85 into this variable. So the variable's on the left, and the assignment, that the value we're assigning, is on the right. So let's start looking at using arithmetic operators with our variables. So here I've set up two very simple variables, x and y, and I'm assigning x the number or the integer and 9, and I'm assigning y the integer 5. Again, remember, variables on the left, values we're assigning on the right. So this looks pretty straightforward. If I print x plus y is going to be added, which is 14, and sure enough, that's what gets output. So that looks pretty simple. Remember that the computer sees this as a plus sign and not a join because these are integers. Integers are not strings, so it can do the math on it, and it does the math. Same scenario here. We can subtract variables. In other words, the program will go in and say what value is in x, it's 9. What value is in y, it's a 5. So I know this should be 9 minus 5, and 4 gets printed out. If we want to multiply something together, some variables or values in the variables together, we'll use the asterisk. So this is saying whatever values in x, which we know is 9, multiply or asterisk that by whatever values in y, which is 5. So output here would be 45. Now that looks a little strange. Now we're doing divides. So this is x divided by y. In other words, the value that is in x is 9 divided by the value that's in y is 5. Well, 9 divided by 5, if I'm not mistaken, if I did the math, would be 1.8. I don't know why it's so hard for me to spit out. 1.8. But why is only 1 being printed out? Because, again, we have to pay attention to how we defined our variables. What data type are we giving our variables? In this case, the data type that we gave the x was an integer. There's no decimals here. The data type we gave the y was also an integer. So the computer looks at this arithmetic problem and it says, well, this is an integer and this is an integer. They must have wanted an integer in return, and so the decimal is ignored in this case and only 1 gets returned. If you know that you really want to, whatever calculations you're making, and you need to preserve that decimal, then we need to make sure that we declare or that we set up our variables so that they are decimals. In other words, if we had assigned 9.0 into x and 5.0 into x, well, now those are floating points. And as a result, the computer says, oh, these are floating points. We need to make sure we maintain the decimal points, all of the decimals. And so therefore, when we print out x divided by y, the calculation is made and the output will be 1.8. So here we're starting to really understand that we have to pay attention to not only declaring what type of our data are we putting into our variables, but how that will affect our output as well. So let me show you one other operator that's very useful, although at first you'll think, well, I don't understand the value of that. I'm going to kind of blow that one off. Don't blow this one off. This is you'll see this one a lot. We call this a modulus or a mod operator. And what this returns is the remainder of x divided by y. In other words, if we look at the problem 9 divided by 5, it's 1 with a remainder of 4. So the output of this print statement would be that remainder, 4. So modulus gives us the remainder, and that does become important later on. So this is used a lot. We'll see that a lot in upcoming code. So in summary, so far we have looked at, we know that we can create variables. That variables are a name that we give to a location in memory that stores some type of data. We know now that we have to declare or decide what type of data is going to be stored in that memory location, so the computer will set aside the appropriate amount of memory allocations or memory slots, or a bucket that fits just enough needed for that particular data type. Data types also determine the behavior of our code. For example, we saw that if we put integers, what we think are integers, into quotations, now these are actually strings and not integers. And so if we use the plus sign, the output will be the joining of these two strings. In order to actually add them, if that's what we wanted, we have to make sure there's no quotations. In other words, make these variables are integers. And if they're integers, the plus sign means that we're going to add them. Okay? And similarly on behavior, depending on what type of data we've declared, remember that's the type of output we're going to get. In other words, if the computer thinks x and y are integers, then we're going to get returned just the integer value. If the computer thinks that x and y, or x and y have been determined that those are decimal data types, then we'll actually get the decimal returned. So now let's look at how our next video, we're going to start actually setting codes up, setting up our programs. See you there.